So we have a few slides from last time. Oh, actually, I ended up doing like 10 minutes of Q&A at the beginning of last lecture, so I got to make sure I say the same things here, if for no other reason, for fairness. But at last lecture, they wanted to know about the interview next week and how that's going to go down, so we kind of talked about it for a while. So if you have any questions, but I'll try to remember all the questions that were asked and answer those ones. And hey, chat is working. Nobody in the whole last lecture asked the message in chat. I was wondering if my internet was disconnected. Can we go over how we should prepare for the interview next week? Perfect. The world is in line. So the interview is going to be where do I start? The TA is going to ask you questions. It will be face-to-face interview style. And while you do the interview, the TA is going to take notes about your answers. The TA is not grading you during the interview. They're recording your responses. So they're going to be typing away. You're going to get nervous, like, what are they typing? They're just typing what you're saying as, they'll use some shorthand and stuff, but as clearly as they can, what you said. And then another team of TAs are going to be the grading TAs, who will not be the TAs in your lab. And they'll review the transcript and then decide, are these answers good enough for the student to pass or fail? Do they demonstrate an understanding of the concepts? The concepts for this quiz are all of the material from last week. So it's classes, objects, references, constructors, the keyword this, assign by reference, pass by reference. I think that's it. Those are all the topics that we're going to talk about. And it's in the syllabus. This is going to be our interview 1, Java basics and classes. So if you're ever wondering what's going to be on a quiz or interview, go back to the syllabus. It will have the descriptions of what each quiz is going to be. I guess it's just a one-liner, Java basics and classes. And then I have my description of what each learning objective is up here for OOP. OOP explain for the interview. Describe the concepts of classes, inheritance, and polymorphism, and how they can help us write software. This is just the classes one. Inheritance and polymorphism are on a separate interview. So we're doing just classes here. And I did name it Java Basics and Classes, but there's really no Java Basics for the interview. The Java Basics that we did, let me back up again. The interview is where we're testing conceptual understanding. Do you understand the concepts that we talked about in class? And the Java Basics concepts are 115 concepts. Like we don't have to ask you what a loop is. How does a loop work? What if I want to store key value pairs in Java? Those aren't good interview questions. It's not, it's memorization at best, and it's 115 concepts at best. They're both good. No need to do that. So it'll be just classes. So classes, the things I just mentioned, classes, and everything that comes with them. Creating objects from classes, using constructors, how references are stored in memory, the keyword this, storing references in your stack frames of non-static methods, all that good stuff. That's what we're asking you about. So you're going to mostly just sit there. The interview is kind of boring. I've been talking about the TAs of what to do during the interviews. I guess you'll just sit there. We did decide that if you're working on your homework, I think that would be a good use of time. Just sit there and work on the programming test while you wait for the TA to call your name. They'll call your name, and then you'll do the interview with the TA. Interviews there's no strict timing for the interview, but I do tell my TAs that if a student hits that 10-minute mark, that you should shut them down using their best judgment, shut the interview down and decide if this interview is going nowhere and it's taken 10 minutes, that they'll cut you off and say, you're done. And maybe you have enough to pass and they say you're done. It doesn't necessarily mean you failed the interview. Remember, the TA who's interviewing you does not even decide whether that is a pass or fail. They're just taking the transcript down. At 10 minutes, they should cut you off. We take into account things like language barriers. For those of you who are non-native English speakers, I do advise the TAs, hey, if it's clearly just taking longer by no fault of the student, that sounds bad, but if it's clearly taking longer for just communication reasons, feel free to go over 10 minutes. We don't want any of those issues, any communication issues affecting your grade and holding you back. So they do watch for things like that. But in general, a general rule of thumb, I tell them to cut it off at 10 minutes. If you know your stuff, you studied, you come in prepared, and you're ready to just talk all about objects and classes and all that stuff, interviews usually last less than 5 minutes. If it gets to 10 minutes, that's usually because the TA asks a question and the student's like, well, gee, golly, I don't know. Hold on, let me think about it. I think classes are like, we use them to create objects or something like that. Hold on, let me think about this. That's when it starts getting to 10 minutes. If you're getting cut off at 10 minutes, either it's a language thing, and hopefully they're giving you more than 10 minutes at that point, or you legit just don't know your stuff and you're trying to pull something out of something lecture appropriate. So that's how it's going to go. It shouldn't be too stressful. The reason, I said this way back on day one, but that was forever ago. So one of the reasons I should say, that we do these interviews is to give you practice with these technical interviews. Sitting across from somebody who's going to grill you on technical concepts, because a lot of your job interviews are going to look like that, and I don't want your first technical interview, to have a job or an internship on the line, like it was for me and many other students before we started doing this in 116. That was the first interview people would get, is no practice, sit down cold with somebody who has a job to offer you, and it usually doesn't go too well because the first interview is tough. Next week, you'll all do great, right? But it's going to be tough. You'll do great next week because there is less on the line. I know there's a grade, there's one application objective at stakes. It's as minimal as I can get it and still have something on the line. Because you can retake it and get the 1 AO. You can earn 2 AOs next week, just a reminder on that. But you can lose the opportunity to earn 1 total AO in the entire course next week, which we haven't talked about in a while. But you can miss 4 of them and still get an A. So, yeah, a little bit of, if you're going for the A, you know what that means. But there's not much on the line. Compared to a job, 25% of your flexibility in still earning an A, or most of it if you're just looking to pass the class, almost none of the flexibility, not too much at stake. So hopefully lower pressure, relax, go in there, study, know your stuff, and knock those questions out of the park. And you'll be good on that. The TAs, the reason I mentioned the 10-minute limit so much, and I do tell the TAs to use their discretion, but usually 10 minutes cut you off. I wouldn't be mad if a TA did that aside from language barriers. So I mentioned that a few times. The reason I'm mentioning that is, say you're last on the list. You're the last one the TA is going to call. You don't want to be sitting there an hour past lab time waiting for the TA to do 20 minutes with every single student. So the way the timing just works out, if you're in a lab with 26 students, each TA has 13 students to interview. If each one of those takes 10 minutes, that's 130 minutes. You only have 110 minutes in lab. We can't do that. So they have to use their discretion and speed up the process at some points if they're starting to fall behind. So that's why I dwell on that a lot. You don't want to be the one sitting there doing, hopefully, your homework for that whole time. And if you are ahead on the class and you're sitting there with nothing to do, well, program test up to 5 is released, so you do have quite a bit to do. I released those 4 and 5 yesterday. So there's quite a bit out there to do right now. I think that's everything. I think I got everything out there. Is the interview, will I be rated on my outfit? And I hope that's a joke, but just in case it's not, no. I wear hoodies and jeans to work. No, we're not judging you on your outfit at all. For job interviews, outside of 116, yeah, they're judging you on your appearance, your, all kinds of things. Your ability to communicate effectively. No, what we're interested in is somewhere in your head is the knowledge that we're looking for in there. If we can get you to say the things that we need, the understanding, not just say the right things, but understand the right things. If somewhere in your brain you understand how references work, that's what we're getting at. I don't care how you're dressed. I can't continue that list. I like the idea of somebody dressing up nice. Yeah, you can dress up nice. Midget is a TA. I think the color says that, right? Are there any other interview practices besides lab interviews? I don't know. If you want general career interviews, the Career Center on campus will do mock interviews with you. They'll go over your resume. They'll give you all kinds of practice with all kinds of things. It's a kind of underutilized resource. They're happy to see people come in there. At least the last time I was down there when I was a student, which was a long time ago, so maybe that's changed. But and honestly, if you came to office hours and said, hey, can you help me with can you like quiz me on an interview, give me an interview question? I'll give you one. I'll try to think of one that I know won't be asked by a TA and throw a question at you. I'd be happy to do practice with that. Yep.
For studying for an interview, like you mentioned, how would you suggest doing that? What kind of studying?
How to study for the interview? Reviewing the lectures last week would be the big one, and making sure that you understand the concepts that were talked about. So I would recommend strongly against memorization techniques, but try to understand what's going on in the lecture. Like if you can understand, I think the hardest concept is the keyword this. If you really understand what's going on with the keyword this, because that implies that you understand references and objects on the heap versus references on the stack. Like really think about that and what is actually happening in memory with that keyword. That would be one of the first things I'd do, making sure I understand that, because that requires a deep understanding of a lot of the topics. Yep.
Yeah, like in the interview, would it be like, how do you do this with a class, or do that, or make this? Would it be like that, or would it be more around concepts? Like
Concepts. I want to give an example without spoiling a question that I know they're going to ask. But you should be able to, for example, explain the difference between an object and a class. Let me think. I had more description in here in previous semesters, but the syllabus was way too long. I had to trim it down. Like, you're going to be asked about classes. It's in the title. So understanding what classes are conceptually would be my answer to your question. Conceptually, what is a class? What's its purpose in our code? Especially when we're using classes to create objects. If a TA asks, why do we even use classes? You better be mentioning something about objects. Oh, we have constructors, and we make objects, and they're stored on the heap, and there's references on the stack. All those concepts you should know. Yeah.
Objects mainly used to store like data values and
Yes. Yeah. So objects are containers that store state and behavior through instance variables and the methods. So their main purpose is to store those values in the instance variables. And then we have the methods that help us work with that data. So we're bundling the functionality along with the data that defines that functionality. How many questions will be asked? Asked twice in chat. For those of you not looking at chat, it is there twice. That's why I said it twice. It depends. If you know your stuff, it'll be a minimum of 2. Just knowing the structure of the interview. It'll be a minimum of 2 if you absolutely know everything and you just spew out all kinds of information. But if you give more vague answers, the TA should be asking more follow-ups. I would say a typical interview should be at least 6 questions. But there are some interviews where we have a lot of follow-ups to questions, and sometimes the TA will ask you to clarify more of your question. They should be doing it more of like a back and forth with you to try to get to the information. They're journeying through your brain trying to find, is the right answer in here somewhere? So if you don't give a right answer, they'll probably ask for a follow-up on that same question, so you'll get more questions. If they ask you a new question, it's probably an indicator that you did well on the first one. I shouldn't say all that because each TA does interview slightly differently. But But there's no solid answer. There's no fixed number of questions. I ask the TAs, ask enough questions to be able to get enough information about the student. So if they ask one question and you go off and just answer all the follow-up questions, first of all, those are the easiest interviews to give. I like when I ask one question, what's classes? And they basically give a whole lecture on like all this stuff. And I'm like, well, that blew away all my follow-up questions. You got this, pass. But if you give shorter answers, the TAs are trained, they are instructed to ask more follow-ups. Because sometimes you know a bunch of stuff, but you're not sure how much to give to the TA for each question. Anyway, it's a whole thing. Your job should be to sit down there, and the TA's job is to get the information out of your head. You show up and know your stuff, you should pass. Okay, so classes are a container for state and behavioral objects store both of those. So classes, objects are containers for state and behavior. Classes can also be containers for state and behavior, but it's less useful. If you make all your methods and variables static, you have a class that stores state and behavior, but it's just not as exciting, I guess, as objects. Really, objects, that's where we're storing the state and behavior through instance variables, through objects on the heap. That's where state and behavior gets more interesting. Having a class with static stuff that stores state and behavior, which we've never actually done in this class. We haven't had a static variable. We've only had static constants for what it's worth. Because if you have a static variable, why not just make it a local variable inside the method? There's not really a reason not to do that. In some cases there are, but really make it an object or a local variable in the stack frame. So yes, they're both containers for state and behavior, but it's less interesting with classes. We use classes to create our objects, have our objects store state and behavior. That's where things get more interesting. Okay, anything else on this? This is about the same amount of time we took in the first lecture, maybe a little more. But so I'm confident we can still get through the slides. And we got through all the slides last time, in the last lecture. Anything else before I get into slides? Let's do it. All right. So last time we left off roughly around here. So let's pick up this and finish up this min example. I want to make sure I revisit this and talk about it, give it the justice it needs, because this does mirror a lot of what you're doing on your homework. Said that 1,000 times last time. Hopefully y'all understand that one, or what I mean when I say that. So we got to this point where we're trying to write this min method, and if, when you get to a situation like this on your homework, some of you will use loops. I'm not going to stop you, but I am still warning you when you get to trees, if you haven't used recursion at all, you get to trees, that's going to be tough. So I do recommend recursion, and I'll give an example in recursion, because we have a new setup here that we haven't seen quite yet, not quite in this way, where we have a method where I want to use recursion, but the method doesn't take any parameters, and I want it to take parameters. Like I want information to be sent to each stack frame. When I create a new stack frame in my recursion, I want to give the next stack frame some information. In this case specifically, I want to give it what node it's going to be processing. So I'm going to be navigating through this linked list where each stack frame is going to process a single node. And that stack frame needs to know which node it needs to process. And I also want to tell each stack frame, hey, here's the minimum value that I found so far. So I'll give it that minimum value that I found so far, and then it can do some comparisons, say, do I have a value that's lower than this value? We got away with this first one in our other methods because we were in the linked list node class. So when we did this.next.recursive call, that recursive call was being called by the next node in the list, which meant this in that next stack frame was a reference to the next node in the list. So we used this to be able to keep track of which node we were currently processing, which node each stack frame was in charge of. But we can't do that anymore because we have a linked list of doubles. This is going to be a linked list of doubles, and we just can't have that same functionality. We'd have to add a method to the linked list node class, but we're not going to go into that class and write a min method because that class uses generics and we don't have a less than operator. So we're in this jam where we can't really do that. We can't use the keyword this. So we're going to write our own parameter instead of relying on that hidden parameter this. we're going to explicitly add a parameter for the node that's being processed and start with the head of the list and start with, I didn't update my slide, with double dot positive infinity as min, not integer. It shouldn't be integer. It should be double dot positive infinity. To be able to initialize my min value to something that's not going to interfere with the logic of my program. This will, if all my doubles are very large, doubles can be larger than the max value of an int. So that's definitely a mistake. I thought I was working with integers when I wrote that line. And then when we start our recursive call, nobody has to care about this recursion at all. We have our public method, min. When you ask for the min of a data structure, you don't want to give it any parameters. You just say, give me the min, no parameters. So our method that sets up recursion, nobody has to care that that exists, that there's this helper method that takes 2 parameters. Nobody cares who's going to call the min method. Whenever you've called a min method using a min method that's written in some language, that's part of a language library, you've never cared how it got the job done, just that it got the job done. People who are calling your min method, same thing. Hide the details, put this in a private helper method, leverage encapsulation. We're going to encapsulate the details, hide the details, and expose the public interface. So inside this recursion, we're going to check this node's value. If this node's value is less than the min value, and the node is of type linked list node of double, so we know its value is going to return a double. This is going to be a double, and I have the less than operator at my disposal now. When that value was type T, I did not have the less than operator. But now it's a double. In your homework, it's going to be a rating, and you have the methods associated with that type. So I can use the less than operator here, check if it's less than min. If it is or isn't, I'm going to make a recursive call moving to the next node. So in the next stack frame, the node is going to be a reference to whatever the next node is in the list. And the decision we're making is this node's value, the one node that we're processing inside the stack frame, is it less than the min value I've seen so far? Because min, for each node in the list, when this method is called, min is going to be the minimum of all the values in the nodes that precede this node. So if the value of this node is less than that value, then when I call my recursive call, I'm going to replace min with this node's value, because this is now the new min. If it's less than the old min, it's the new min. If it's not less than the old min, just forward min to the next stack frame. We're going to keep doing this until we get to the end of the list. Now I'm doing this in a little bit different way to show you a few different ways to set this up. Whatever you do on your homework, you do have to make sure that you're checking the last node. However you want to set it up, however you want to get that done, make sure you're checking the last node. Make sure you don't, one, go past the last node, because you'll get a null pointer exception. You'll start seeing those on this homework if you have bugs. A lot of them will be null pointer exceptions, which I don't think I've mentioned in either section yet. I have to remember to mention that in the other one. But a null pointer exception is when you have a variable that is supposed to store a reference, but instead stores null, and you try to use the dot operator. Dot operator means follow this reference to its object on the heap. If you use the dot operator on null, where's it going to take you? It doesn't take you anywhere. It crashes your program is what it does, and it throws a null pointer exception. Program crashes. Can't follow null. So you have to have these null checks. If I have null, don't try to use the dot operator, because this would get you a null pointer exception if node is null. So to check for the end of the list, I want to make sure I do check the last node, because the last node might have my minimum value, and I don't want my code to break in that edge case. So I'm going to check the value. So let's talk about the instance of when this is called on the last node of the list. So we go through the whole list. We get to the last node. That node is not going to be null. We're going to check its value, make a recursive call with node.getNext, which will be null. We're going to call the method with null as the parameter. Node will actually be null. And then we're going to check if node is null. What that means is we're not at the last element. We're actually beyond the last element. We're at that null after the last element. And then at that point, there's nothing else to process. Even the last node has already been processed when this is the case. We just did that check and then made the call with null. So then we can just return min. Min is the minimum value of all the nodes that have already been checked. If we're beyond the end of the list, that means we've checked the entire list. And min is the overall min of the entire list. So just return it back to the calling stack frame, which just returns it, all the way back to the min method, returns it, and then this returns to whoever called min and gives them the final answer. If the TAs ask you what is life and you give a good, convincing answer, I think I'd be happy with that. I think I'd just give you an A. If it's an answer that can help me improve my own life, I'd probably just give an A. If you have a solid answer. I want to skip these slides and get to today's slides, because today's slides do start with those slides that I just skipped over. So let's delete a node. So for your homework, the homework, I don't think, anyway, some of you might disagree, so I want to hedge my wording here a little bit. I don't think homework 3, programming test 3, is too difficult until you get to deleting a node. Deleting a node is the tough part, and with deleting a node, I'm going to show you conceptually, I'm going to show you the image of how to delete a node, but I'm not going to show you any code for it. It's up to you to figure out how to write the code for that and how to get that job done. How to delete a node. Because it does get a little tricky. That's the bulk of the difficulty of programming test 3 by design. So if you get through the getters, the setters, the average, you test the average method, you write your average method, and you're like, man, I'm doing good. You know what? I'm going to wait till the night before the deadline to do the rest of this thing. I'll do deleting a node later. And then you do it right at the end of the deadline. Just keep in mind that delete is intentionally the bulk of the difficulty of the homework. So don't put that off for last and take it for granted. That is where things get harder. I don't think too hard, but there are just a lot of little tricks to it. So let's go over deleting a node. I want to delete, say I have this is my linked list, and I want to delete this node, the node containing the value 2. What I need is a reference to the node that comes before that node. So if I want to delete the node containing 2, I need a reference to this node that comes before it, this node with 3 in this example. And what I'm going to do to delete that node 2 is update this next to be next.next and set it equal to whatever that next value is. And I'm just going to cut that node out of the list. So if I update this reference to, instead of being whatever it refers to, it'll be whatever it refers to's next, I just deleted a node. On the slide, it looks really simple. We just updated one single reference and we deleted a node. Something that's very expensive to do in an array list or an array, by the way. If you delete a node in the middle, a value in the middle of an array list, everything that comes after it, you have to move down by one index to get everything sequentially in memory again. With a linked list, you update one reference and that's it. You deleted a node. And then that node is going to be a candidate for garbage collection. Unless somewhere else in our code we happen to, for some reason, have a reference to this node, it will be garbage collected and it will actually be deleted from memory after we only updated a reference. The JVM is going to go in and clean that thing up. Yeah.
Wait, so is it like we're skipping over it or fully deleted?
It will be deleted by Java. We're just skipping over it.
Okay.
So we don't actually delete it. There's nothing where we actually delete this node. We're updating the value stored in this variable, and that's it. That's deleting a node in a linked list. Mm-hmm.
Just the one before it. We don't gotta do the one before it and after it?
Nope. No, because this one didn't change. We didn't change anything here. It still just refers to this node. We just had to update this value. This node, nothing changed here. It still has the same value, same next. Nothing changed with any other node except the node that comes before the one we're deleting. Yes?
In Java, can you do like this dot next is equal to this dot next dot this dot next, something like that? Like can we chain multiple dots? Like multiple method calls?
Yeah. Sure we can. We had an example where I chained like 3 of them together in a memory diagram. As long as the method that you're calling returns a reference, you can keep chaining dots together as much as you want. Get next returns a reference. So you can do get next dot, get next dot, get next dot, get next dot, get next. But if you're doing that a lot, you do have to check for null. It is a common office hours question that I'm sure I'll get by probably half of you. Check for null. If you're ever doing get next, get next, and one of those nexts was null and you're calling dot on it, you're going to get that null pointer exception. And what's even worse is you're going to get that null pointer exception when you submit your code to Autolab, because my incorrect solution will not have a next. It'll have null because it's doing the wrong thing, and you're assuming that it's doing the right thing, but it's an incorrect solution. I've explained this a billion times. I will have to next week in office hours explain it a billion more times. Don't assume that get next doesn't return null. Okay, so 3 tricks here, and I gave some hints in the other lecture, so I'll give them here too. 3 tricks here. 1, you need a reference to the node before the node you're going to delete. So when you're going through this linked list, make sure you don't get rid of a reference to a node, and I kind of mentioned this last time, but here I'll be more explicit. You don't want to get rid of a reference to a node until you know that its next isn't a node that you want to delete. So if I'm going through this list and I'm iterating, when I'm at this node, I have to look ahead to this node and see if this is a node that I want to delete before I get rid of this reference. So I have to check the next node when I still have a reference to its previous node. Because this is a singly linked list, we can't ask for the previous node. Then I go on to this one and check, is this node a node I want to delete? If yes, then I still have this reference in memory, and I can update next and get that next node out of there. The second one, what happens if the node I want to delete is the last node in the list? I've been harping on this all week, so hopefully this isn't brand new news. But however you're checking your code, make sure you are checking that last node. Don't say, well, if get next is null, then I'm done. Make sure that last node gets processed. It's an easy, simple mistake to make. See a lot of students make that very often. And 3, what happens if the node you want to delete is the first node in the linked list? So for those last 2 things, what happens when the node you want to delete is the last or first node? There are incorrect solutions on that, and my tests are going to test that. But my tests should be irrelevant because you have in the incorrect solutions, and you'll pass your own tests that test for those things. I didn't used to have it in the incorrect solutions, and that would be a lot of the office hour questions of, well, Autolab says my tests are good, and I'm passing my tests, but I'm not passing your tests, and it's because I was deleting the first and last node, and their tests weren't. So there are incorrect solutions. I'm explicit. I'm mentioning it in lecture. We're not going to have those questions again. You know your task. And then it's your job to solve the technical problem and get that task done. I don't like the homework questions where you're wondering, what do I even have to do here? That's what you have to do. So that's your challenge for deleting a node. Those 3 things. I gave this, let me make sure I remember, and I'll talk about it again when we get to queues, is if the first node is the node that you're deleting, well, that node is stored in an instance variable in the song class. You're going to have to update the reference stored in that instance variable in the song class. That's how you delete the first node. That is an edge case. It's got to be handled differently in your code.
If it's the first and last, we just set it to null, the reference to null.
Yeah. Yeah, if there's only one thing in the thing, and you got to delete it, but we're getting too far into, I'm already given enough hints. All right, stack and queue. So stack and queue are data structures. We're going to build these on a linked list. And stack and queue are made to be efficient. That's really their main goal. They're data structures that are going to have stripped down functionality, and the only functionality given to you are efficient methods. So let's build these things. First, what is a stack? This is our last in, first out data structure. We should be pretty familiar with this. Our memory stack is a stack of stack frames. All we can do is add things to the top of the stack and remove things from the top of the stack. I always think of it as a stack of folders or papers. I can add a folder to the top. I can remove a folder from the top. And yeah, sure, we could pick up half the pile and remove something from the middle. But the concept of a stack says, nope, we can't do that. Add to the top, remove from the top, that's it. And these methods are called push and pop. If you have these 2 methods, you can push to the top of the stack and pop from the top of the stack. You got yourself a stack. And this, conceptually, the concept of a stack is just these 2 methods. It has these 2 methods, and that's it. Some implementations of a stack, not the one we're going to build here, but some implementations will have a third method, usually called top or peak, which will return the value of the top of the stack without removing it from the stack. It can be helpful for programming, but the concept of a stack, and that's really what I want to focus on with stack and queue. I'm not going to test you much on stack and queue, but the concepts, for no other reason, are important because actually these concepts are just really important. You need to understand these concepts. For stack memory, understanding that you can only add a stack frame to the top of the stack, that's the active stack frame, and you can only remove that stack frame, and then the one that was underneath is now active. Like, understanding that concept is important too. But also, these make great interview questions. Interviewers love, not necessarily in 116, but job interviews, linked list, stack, and queue. Man, they harp on these ones so much. These are a lot of the questions. So let's see this in action. We'll create a new empty stack. Push 1, that goes on top of the stack. Push 2, it goes on top of 1. Push 3, it goes on top of 2. And then when we pop, we're going to pop whatever was on top of the stack, remove the top element, and return it. So since we only have push and pop, pop is going to have to return the value as well. So pop has 2 jobs to do. That's why some implementations have that top or peak, which will just return the value without removing it, in case you don't want both. So that's what a stack is, that's what it does, and here's how it does it. Here's the code. We're going to have an instance variable for a linked list that's going to store a reference to the top of the stack and build this stack using that linked list. And we're going to prepend to the linked list to push, and we're going to remove the first element from the linked list to pop. So push, and we're initializing this to null. Remember, null is how we're storing a linked list. There are, out there in the world, there are other ways to do this. In this class, the way we're using a linked list, having it have a reference to null, that's how we're indicating an empty list. Do not create a new linked list node of null, null. I see that too much. New linked list node, null, null. Setting that to top or to your ratings linked list in your song class and saying, that's my empty linked list. That's not an empty linked list. That's a linked list of size 1 that has the value null. Don't make that mistake. Just set it equal to null. And then throughout our code, we're going to have these null checks. We're going to check if it's null. If it's null, we know it's empty, and then do whatever we're supposed to do when it's empty. So to push, this is the same as prepend. Last time we saw prepend, I did it in one line. This is the same as saying this.top equals new linked list node of value this.top. We just have a temp variable here, same effect though, and have it in a method. So we're prepending the value when we push. So the front of our list is the top of our stack. And then when we pop, we're going to check if the top is null. That means we have an empty stack. We're trying to pop off an empty stack. Many implementations that you use, like if import java.util.stack, I think it's java.util, and start using that stack, and you try to pop off that empty stack, it'll actually throw an exception. And if you don't catch that exception, it's going to crash your program. That's common across a lot of languages. We're not going to get that crazy with it. We're just going to return null if we try to pop off an empty stack. But really, just don't pop off an empty stack. Be careful with your stacks. They'll pop off them, and you don't have to worry about that. Don't pop off an empty stack. If the stack, bless you, if the stack is not empty, that means top does have a reference to a linked list node. We can safely use the dot operator on it because we know it's not null. We're not going to get that null pointer exception. And we want to update top, this.top, to this.top.getNext. So we're updating top to refer to the second node in the linked list instead of the first. And before we do that, we have to grab its value because that's what we need to return. Once we hit this line, we no longer have a reference to the old top of the stack, so we can't get its value anymore after this line. So we want to make sure we grab that value so we can return it and then update the reference. So that's push and pop. Visually, it's going to look like this. Say we run this code. We have this linked list where top is a reference to the head of the linked list. We have this linked list, and this is the top of the stack. So we have a stack with 2 on the top, then 7, then 3. When we push a new node to this, we push -5, we're going to update top to a new node where its next is a reference to the old top. Just like prepend, same thing that we did with prepend. And when we do this, what's in the red box here is the old list. That's what the list was before we pushed -5. And notice that that list didn't change at all. We didn't have to do anything with the rest of the list. We just created a new node, set its next equal to the old head of the linked list, and then updated this variable top to be a reference to that new node. What I just said there is the same no matter how big this stack is. If I have 3 elements or 1,000,000,000,000 elements, it's the same amount of work. Create a new node and update a reference. And nothing changes with the list at all. Same thing when we pop. We're going to pop that -5. We update top to the next node, and that's it. We just deleted a node. We did that through reference variables, just like if you have to delete the first rating in a linked list of ratings in your song class, you update the instance variable to refer to the second node and leave this one out to be garbage collected. That one's going to get eaten by Java. And notice that our original list still didn't change. Even if we popped again, we would update top to be a reference to this node. We still wouldn't change the original list at all, except the node with 2 might get garbage collected. But we don't have to go through this whole list and process anything. We're updating references. We're creating nodes if we're pushing. And both those operations, push and pop, are O of 1 operations. We don't talk about runtime much at all in this class. I think this is the only lecture where I'll touch on it. 250 is going to be all about this. It's all about runtimes of different data structures and proving that they're correct and analyzing their runtime. But very briefly, more of a foreshadow right now is O of 1 means they're constant time operations, which means it doesn't depend on the size of the data structure. When I say whether it's 3 or 1,000,000,000,000 elements, we do the same amount of work. That's big O of 1, or constant time operations. Very fast, very efficient. Push and pop are both very efficient, and that's what we want out of our stack. All the other methods that we looked at were all O of n, where n would be the size of your data structure, and that's going to scale. That means the runtime scales linearly with the number of elements in your data structure, which is a much, much slower operation once you start getting a lot of elements in that data structure. So a stack and queue, they're restrictive data structures. They're taking a linked list, taking away most of your functionality, and just giving you these 2 methods. Very restrictive, but it's forcing you to only use efficient operations. And notably, something missing, at least from the concept of a stack, you can't ask a stack for its size. You can't say, hey, stack, how many elements you got? Now, some implementations might have that functionality. It might have an instance variable for size, and then increment it when you push and decrement it when you pop. But the concept of a stack doesn't know its size. It's just those O of 1 operations. Very efficient. It doesn't let you be inefficient. Which, for my money, I say just use a linked list and use it responsibly, but in your code, but the concept is still important. All right, so queue. We know what queues are. You queue up at the back. You dequeue at the front. This is our first in, first out data structure. And with this, just like push and pop, we're going to have in queue and dequeue. We're going to in queue at the end and dequeue from the front of the queue. It's going to work like this. We have this queue class. We're going to create an empty queue. The way it's going to work, its behavior is going to be in queue is going to add to the back. So we in queue, 2 has to queue up behind 1, 3 has to queue up behind 2 at the end of the queue. And when we dequeue, we remove from the front. So 1, 2, 3 queued up. And then when we dequeue, we take whoever's been waiting in line the longest. They're going to be the one that's removed and returned. Yep.
So it's like ordering stack token first?
Kind of, yeah. So they're like added in the same way, but removed from the other end. And here's our implementation. It's very similar to a stack with one big, big difference is that we have to work from the front and back of the queue. If we only stored a reference to the head of the linked list that we're going to use, then whenever we have to go to the back, whenever we have to append to the back of the queue, we have to do an O of n operation, which is way too slow. We don't want that. We want these both to be O of 1. Our solution to this is to store a second reference, which is going to be a reference to the back of the queue, and then we're going to update front and back as we go through the queue. So when we in queue, if back is null, that means front is also null. That means we have an empty queue. We're going to create a new linked list node and set back and front equal to a reference to that node. If the queue is not empty, that means we can safely use the dot operator. This is not null. And we're going to append to the back. This is just like our append operator, except we don't have to find the end of the linked list first. We just add. We just do the append operation without any extra work. And then dequeue is the same as pop off a stack, except if we pop the last node, we want to do a little bookkeeping and make sure back is also going to be set to null if we dequeue the last element. Other than that, it's the same as pop off a stack. So let's see this in action. We'll get to the end of this. I have faith. 1 minute. We can do this. So when we in queue 3, first, front and back are both null. We in queue 3, they're both referencing the one node. We in queue 7, front happily refers to the same node, the front, but back is going to update to the new nodes that are created. When we dequeue, we're going to update front to refer to the next node and return the value. Let that node be garbage collected. Dequeue again, front advances. This gets garbage collected. And when we dequeue the last element, we have the extra bookkeeping. We don't want back to still refer to this node because it's no longer part of the queue. So we have to make sure we update back to be null as well. Front will naturally just get this null. And back, we have to say, oh, front got null. Back, you better store null as well. What if we dequeue from an empty queue? Well, we return null so our program doesn't crash. But guess what? Our program crashes anyway because x is of type int, which only stores a value, not a reference, and we're trying to assign it the value